Good afternoon, ladies and gentlemen. I'm Art Winnie today as a presenter from one of the finest display society in the world. Today, we will learn a novel power-saving technology for OLED TV with iterative compensation. My name is gungs, research engineer in LG Display. Like many of you, I love my work and many works I've done for OLED development. If you love OLED TV, you can get to love this talk. On our agenda is 5 things: history, problem, solution, benefits, and conclusion. Then, let's get started. What's the history of OLED TV development? OLED display is very suitable as future display because it's thin and lightweight panel with vivid images of wide viewing and high contrast ratio represented. But it's difficult to make large-size OLED TV and require breakthrough to mass production. Oxide TFT backplane technology is a very good solution for this problem. It's amorphous-based semiconductor with high current driving capability for Gen 8. But there are issues such as unpredictable threshold voltage and unsatisfactory stability. External compensation technology has a strong merit to solve this problem. It can make great TFT compensation and give high aperture ratio and panel yield by reducing a number of TFTs. But it uses high voltage by adding unpredictable offset to video data. That's why you have to remember adaptive SVDD. This is the solution to reduce power consumption and increase image quality by optimizing voltage. What's the SVDD? Where is it? You can see the control PCB in the picture. It includes T-con, memory, power IC, and programmable gamma IC. And it's connected to source drive IC in the panel. SVDD is a voltage generated by power IC, and it supplies power to P gamma IC and source drive IC. On the system, power is divided by 2. One is for an electron luminance voltage, another is for the logic voltage. Logic power generates voltage for driving IC. First, this power makes a T-con, and T-con controls power IC. And power IC generates SVDD, and it is supplied to P gamma IC and a number of source drive IC. What's the role of SVDD? SVDD is used to amp of DAC, and it has an important role for generating voltage. As shown on this picture, SVDD should be higher than generated voltage. Then, why is focused SVDD? Because SVDD is the highest portion in logic voltage. You can see the 3 different patterns and check the SVDD's power portion in logic power. It's different according to a circle pattern. H19 and standard movie require more power than pure white fixed pattern. It means dynamic output of DAC increases power consumption of SVDD, and also means SVDD is more required at high refresh rate or high resolution display. So, what's the problem? You can see the current equation of TFTs in the saturation condition. Kn voltage of this equation is a unique picture of a TFT. And it's different among TFTs. This difference makes a variation. For load variation among TFTs, these parameters must be raised. How is it possible? The solution is the VGS includes mobility and voltage as well as V data to remove K and voltage in the first equation. External compensation can be possible there because it generates VGS including these parameters using external circuit. Check the different structural elements of input voltage. Left is conventional method using in-pixel compensation. In this case, V data range means input voltage range. Right picture is an external compensation technology. External compensation needs additional values like mobility and VTH and its margin. That's a problem because these additional range require higher input voltage range and high SVDD. In this case, VTH margin should be included because VTH is increased by the stress. If VTH is predicted to be high voltage, you need a margin to make high voltage. It's important because it means performance of compensation. At this time, you can have a question. Is it possible to reduce the additional voltage? Sure, you can do it. VTH margin is the point. VTH margin can be erased if you know VTH when T-con transfers compensated data to panel. Actually, T-con already know VTH of TFTs because it drives externally in external compensation. VTH margin is overhead. If this overhead is removed, you can reduce SVDD by 25%. Did you catch the point? You could see the problem of overhead voltage, and it's possible to reduce SVDD. Then it may be required. How can you solve the problem of overhead voltage? There are two processes like data compensation and sensing parameters to solve this problem. In this page, you can check the 3 steps for the process of data compensation. First is data conversion. Input grade is converted to free data according to input voltage. Second is read parameter. In this step, T-con reads TFT parameter like VTH and mobility from DDR memory. Last is compensation. Compensated V data is made by calculating V data and parameters. Through this process, you can remove the variation among TFTs. Then, how can DDR memory get these parameters? The solution is the next page. For getting TFT parameters, there are 3 steps for the process of sensing parameters. Step 1, VTH extraction and find the maximum VTH. T-con senses TFT parameters and overrides VTH from ADC in source driver IC. As time goes by, VTH distribution is widened and maximum VTH is increased because of the stress. In this process, change value is detected by the T-con by searching VTH. Step 2, voltage generation. Improved SVDD and V gamma is generated by maximum VTH. Step 3, write parameter. T-con writes parameter DDR memory for using compensation. Then DDR memory remembers these parameters. Through this process, you could check removing overhead voltage, then how your SVDD is changing. VTH is increased by the stress as displaying time. As you can see, VTH is gradually increased as time goes by. It means optimization voltage is generated according to stage of panel. Then, what are the benefits of reducing SVDD? Adaptive SVDD has strong 2 benefits. First, reducing power consumption. It reduces 1.8 watts, and it means power of SVDD is decreased as 30.6%. Second, increasing grayscale. It is possible by input voltage range is increased as 25% relatively, from 75% to 100%. These results are totally verified by 55-inch OLED TV. And if we adapt this to the display, having higher resolution or faster frame time, you can get more effective result. You can get the conclusion in front of the scene of a beautiful city, SanDiego. External TFT compensation is additional voltage such as VTH and mobility. Here, VTH margin is included as a predicted increase of VTH. In this situation, if you know maximum VTH, you can set optimized voltage range. From this idea, adaptive SVDD reduced 25% voltage by removing overhead. Try this, then you can reduce power consumption and increase grayscale with no side effect. How to think about adaptive SVDD? This technology is going to be helpful to make better OLED TV. Thank you very much at this time. I'll be happy to answer any of your questions. Thank you.